hello, my friends and foes. I know you were looking forward to not having to hear my voice today, so I am sorry to disappoint. We are going to work through the rock cycle notes that we have here. So you should see there is a triangle, 3 points for the 3 types of rocks that we have. Down at the bottom it says the rock cycle. We're going to start up in the top left corner where it says creation of sediments, because that's the one that we've spent the most time with recently. So the first one says creation of smaller pieces of rock through physical or chemical means. So we've talked about physical and chemical weathering. So this first blank here is just going to be weathering. I do ask that you use 3 different colors on here. Those of you that hate colors, I apologize profusely, but we're going to make this little thing pretty. So I don't really care where you throw in the colors. If you want to color in stuff here, go for it. If you want to add some pictures of rocks, of sediments, whatever, that's fine, but you're going to add colors here. So after weathering, the next one says the moving of weathered products from their original position. So we've talked about how the movement of weathered products or sediment is called erosion. So we have erosion and weathering, and hopefully that means that you can surmise what the last blank might be. The settling out of sediment, we call that deposition, the depositing or deposition of sediment. So that's when sediment stops moving, when it settles in one spot. So these 3 are the creation of sediments, and then once we have sediments created, we have 2 processes by which sediment is squeezed and glued into a rock. So sediment is compacted and cemented. So the names of these processes are compaction and cementation. So compaction, cementation, those are all the processes that lead to the creation of sediments. So our sediments are little bitty pieces of rock. We talked about that on Friday. And those pieces of rock are layered together. And once they're layered, they get compacted, which means all of the extra space in between there, all the fluids, all the air between the sediments start to get squeezed out. We call that compaction. And then they are glued or cemented together, often with water that's been mixed, that's filled with minerals and things that harden when they're dried. We call that lithification. Lithification is just like when it's turning into a rock. Those of you that are perfectionists, I really apologize for my coloring in there. It looks horrible. So, since we're already talking about sediments and sedimentary rock, we're just going to pop down to the bottom left of our triangle. So it says blank rock created from the blank of blank in blank over time. So this first one is our sedimentary rock. So we have sediment, sedimentary. Sedimentary rock is created from the deposition of sediments in layers over time. So the settling or the dropping of sediments, little pieces of rock, in layers over time. We call those layers strata. So that was one of your terms on the sheet that you guys did on Thursday. So sedimentary rock created from the deposition of sediments over, or in layers over time. So that brings us to our arrows. So our arrows are very important because our arrows are the start of the rock cycle. So we said that sedimentary rock forms from the deposition of sediments. So in order to have sedimentary rocks, we need to have sediments. So we end up with sediments through weathering, erosion, and deposition. So we abbreviated that to WED last week. We're going to keep that up. So WED, weathering, erosion, deposition. And then once we have those sediments, they get compacted and cemented. So we're going to do weathering, erosion, deposition, and compaction cementation. So we got a lot going on to form those sedimentary rocks. So that's how we get to sedimentary rocks. Same thing over here. No matter which way we're coming from, in order to get sedimentary rocks, we need to have weathering, erosion, deposition, and that compaction and cementation. Gets a little bit tight there, so sorry. So weathering, erosion, deposition, and compaction cementation lead us to our sedimentary rocks. Last week, we also talked about metamorphic rocks. That was on Thursday. We talked about how shale can become slate. We talked about limestone becoming marble. Those both started out as sedimentary rocks, but they turned into metamorphic rocks. So in the right over here, oh golly, in the right over here, we have metamorphic rock. So metamorphic rock is formed by existing rocks that are subjected to very high heat and pressure. So this whole very high thing, like, that's important. It's not like you can go cook yourself a metamorphic rock in your oven. These are extremely high temperatures and significant amounts of pressure. So metamorphic rocks, we'll do dots on this one. How's that sound? Metamorphic rocks over here, heat and pressure form our metamorphic rocks. So since heat and pressure forms metamorphic rocks, what that tells us is this arrow right here is going to be labeled heat and pressure. So what we'll talk about tomorrow is that the rock cycle is not very not linear. It's goes in lots of weird directions. So what I always say is focus on where it's coming from and where it's going. So if it's pointing to a metamorphic rock, it's always going to be heat and pressure. The only way that we have metamorphic rocks is through extreme heat and pressure. So right up here we have another arrow that's pointing to metamorphic rocks. And we're going to label it, you guessed it, heat and pressure. So right over here, I'm just going to jot down heat and pressure. Metamorphic rock is always heat and pressure. Now, after metamorphic rock, we are left with exactly one type of rock. Hopefully you already know what it is. It is my personal favorite, because everybody has personal favorite rock types, right? So, igneous rock is what we are left with here. So, igneous, I-G-N, igna, means fire. So, igneous rock comes from magma or lava. So, we learned on Friday about the two types of igneous rocks. Those are extrusive and intrusive igneous rocks. We learned that extrusive igneous rocks form on the Earth's surface, and intrusive rocks form inside the earth. So interior and exterior. An interior door, of course, would be a door that's inside your house. An exterior door would be one that takes you outside. So extrusive is outside or on the earth's surface, and then intrusive is going to be within the earth's surface. But no matter whether we're talking extrusive or intrusive, they are both created from the cooling and the solidification of magma or lava. We've talked about magma and lava before, but just a quick refresher. Remember, both are made of molten rock. And molten just means liquid, like melted. And magma is molten rock that's below the Earth's surface. Lava is above the Earth's surface. So just like we have that differentiation with our intrusive and our extrusive rocks, we have that with our magma and our lava. So, in order to have igneous rock, what has to happen is that we have to melt rocks, and then those melted rocks have to cool to solidify as igneous rocks. So for instance, we might have a metamorphic rock like gneiss, and that gneiss gets buried deep within the earth where it's super hot. Once rock gets really hot, it might melt. When it melts, it forms into magma. That magma could then cool and form, let's say, obsidian. So we have igneous rock formed from the cooling of magma. We are going to do squiggles on this. How's that? I know you guys are really invested in my drawings here. So we have our igneous rock. Since we have an arrow here leading from sedimentary rock to igneous, we're going to go ahead and label that one as well. So just like we said, our gneiss melted and cooled to form obsidian, we could say over here that our sedimentary rock of sandstone. It was buried deep within the earth, where it then melted into magma. That magma then cooled, and let's say this time, formed a nice, lovely granite. Granite is an intrusive igneous rock, which of course means it forms below the Earth's surface. So melting and cooling, no matter what, is always going to lead us to our igneous rock. Weathering, erosion, and compaction, deposition, compaction, and cementation are all going to lead us to our sedimentary rock. Heat and pressure, no matter which rock form or which rock type we are starting with, are going to lead us to a metamorphic rock. So, now that we've got our 3 rock types laid out here, I do want to mention here that it says any type of rock can transform into another type of rock under the right conditions. In addition to that, we could have a piece of pumice that formed from an erupting volcano. So that would be an igneous rock, right? Maybe this pumice falls back into the volcano where it then promptly melts again and it turns back into magma. So we can get stuck kind of in this same part of the cycle where we have melting, cooling, and it's staying in the igneous rock. Sedimentary rocks. Sandstone, we already talked sandstone. Let's talk limestone. Limestone is a sedimentary rock. Limestone can be weathered, eroded, and deposited just like any other rock. So it could be turned back into sediments, which then could be created by, or could then be deposited and create a sedimentary rock. So we could have sedimentary rocks can be formed by sediments of sedimentary rocks. Metamorphic rocks, we have some examples of metamorphic rocks which are formed from other metamorphic rocks. So if we have a metamorphic rock that goes through heat and pressure, it can become a new metamorphic rock. So lots and lots of kind of chaos with the rock cycle where we can go lots of different directions. We are going to talk more about that on Tuesday. So we've talked about a couple rock types here, or a couple examples of rocks. So pumice is my good old friend igneous, because pumice is the one that it can float in water, so that's kind of fun. Obsidian and granite, of course. So pumice and obsidian are extrusive igneous rocks. Granite is an intrusive igneous rock. We know that because it's got those larger crystals. Shale, sandstone, and conglomerate. Conglomerate is the one that looks like a bunch of little pebbles that were glued together, which is essentially what a sedimentary rock is. So sedimentary rock for our shale, sandstone, and conglomerate. And that leaves us, of course, with gneiss, marble, and schist, which are all metamorphic. Now that you've got all this beautiful information, I want you to make it even prettier by adding lots of lovely colors. So I just picked 3 colors to write with, but you're going to go in and you're going to make yours look schmancy, because schmancy things are so beautiful. So throw some colors in there. Make it look nice. Make sure all the information's on there. Let me know if you guys have any questions, and I will be back with you tomorrow.